So the big mart sales problem, which is there in analytics vidya, we generally use it for discussing what you call data pre-processing, but because the data has a lot of pre-processing activities which you can do on the data. Okay, so we have got two data sets, train data set and test data set. Remember, always you build a model on train data only because that is the full data with dependent variable. Test data will not have the dependent variable, which needs to be predicted based on the train data model. So that is the context of the train and test file. In competitions, hackathons, you get two files, train file and test file. You have to predict on test file, copy them into sample submission, and you upload it into the competition site to check your rank and accuracy. Now, we have combined the data frame. So for pre-processing, we have combined the data frame. We have concatenated. Concatenation means side-by-side pasting. It can be column side-by-side pasting or row up and down pasting. Concatenation. Concatenation is different from join, because joins you have different. Left join, right join, inner join. So they are different. Concatenation is simply pasting side by side or up or down. It's a simple process. So we have, but for concatenation, the number of columns should be equal. The sequence of the columns should also be same. For concatenation, the number of columns should be equal and the variable sequencing must also be same. Now, if variable sequencing is not same, what will happen? It will concatenate, but it will create new columns and it will create missing values. It will concatenate, but it will create separate columns for different variables and it will create missing values for empty cells. Again, it's a problem for you to. So make sure when you are concatenating, the sequencing is also same. So here I have added the dependent variable to the test data and fill that with the word test for concatenation. And across Python, axis is equal to 0 refers to rows, axis is equal to 1 refers to columns. Wherever you see the word axis in Python is equal to 0 represents rows, is equal to 1 represents columns. You will see axis in different arguments. So axis, wherever see, either it will be 0 or 1. If it is 0 rows, 1 is columns. Then we found out the missing values in the combined data frame. The function for identifying missing values is null. Is null is the function, predefined function for identifying missing values. Sum is for totaling and sorting is for descending order sort, because we want the missing value cells on top, non-missing value in 0, because we are bothered about the missing value numbers. Then we have also checked the percentage by dividing with the shape. Now the shape output has two things, rows and columns. First is rows, second is column. So shape 0 refers to rows, shape 1 refers to columns. Got it? Dot shape will give you two outputs. First 0 output is row, 1 output is columns. Okay, this also you have to remember, because you constantly, so client will ask you do percentages and all, you always do divided by rows, right? So dot shape square bracket 0. That is how we will do. Then we found out the percentages, and based on the variable type, outlet size, missing values are very high. We can't add it to the existing categories because it might create a bias. So I have kept it as missing only, because adding it to existing categories, it might lead to bias. Bias means favoritism, and that will create problem in data. Bias is a problem in data science. You should not have bias when you are doing data analysis. It has to be as much as possible unbiased. Unbiased means you should take the true facts. By adding them, you are creating a biased categories. To avoid doing that, we will keep it as missing only. So I have imputed the missing in outlet size with the word missing, so that I don't create a bias in my data. Always when you're confused, when you can't decide, keep it as missing. Safe strategy. Safest strategy is keep it as missing or not available. When client gives you further information and then says, okay, let us do this side of imputation, then you can go and do whatever he says. But if he wants you to take a decision, take a safe decision, keep it as missing or not available. Safe side. Then in weight, we found out the mean and median are closer to one another. So we have done mean imputation. You can use mean or median. When will you use median? When the number is whole number, we will use median. When there is a decimal, we use mean. That you remember. Sometimes the data has whole numbers. Then you only use median. Don't use mean.
So what happens if you use cross? Mean use median.
No problem. For mean, using median is not a problem. For median, using mean will create problem. You will have what you call, you have, suppose 1, 2, 3, 4, 5 rating scale is there. 1, 2, 3, 4, 5. That's how the rating is given for employees in organization. You won't give 4.33 rating, 4.26 rating, 4.28 rating is not given, right? Either you should give 1, 2, 3, 4 or 5. That's all. No 4.56, no 4.68. There is no such thing in the organization thing. Then how can you give? If you do mean, you will get a decimal compulsorily. Right? You do a mean of the values, you will get a decimal. Is it allowed in your data? It is not allowed, right? So you have to look at the data type. So if a particular whole number is given, there is a reason for giving a whole number there. Okay, so that's why we have float 64, which is decimal, int 64, which is your whole number. So two different data types are there. Int 64 is whole number. Float 64 is decimal. 64-bit, based on all laptops are 64-bit. That 64-bit is the value of the bit size of the whatever operating system we are using. Then we have done the imputations. Once we have done the imputations, we have done processing like extracting information from item identifiers. Now this also you have to observe. You have to observe and you have to be a little bit creative and see how we extract the information. Sometimes the codes will be in middle. Here it is in the front. We could cut it up. Sometimes they'll be in middle. So you have to go, the slicing will work in the middle also. You give that range of numbers, 5:7 or 4:6. Wherever the code is there, wherever you think the code is there, either in the numerical format or alphabetical format, you can use the slicing. Where you have to count the characters. When you're counting, start from 0. That is one thing you always remember in Python. Whenever you count something in Python, it always starts from 0. Okay, so I have extracted the first 2 letters and we found out there are 3 categorizations: food, non-consumables, and drinks. Then fat content has duplicate levels. So we have corrected the duplicate levels, right? Duplicate levels are there because of data entry mistakes. We have corrected them into 1. Then we have checked each every variable. Then we have calculated a new variable called outlet age based on establishment year. Whenever you have date, we have to extract information from date and then we have to drop that column. Date is only used in time series data. Date is used only in time series data. Time series data, when you do time series analysis, there are different set of algorithms and different models for time series, like ARIMA, which are only for time series. So in that data, date column is very important. So we have to keep date there. But in normal machine learning, we don't need date. Before dropping date, we will see, can we extract any information? What information can you extract? We can count the difference between 2 dates. We can count the difference between 2 dates. Loan applied date, loan approved date. 2 dates are there in my data. Loan applied date, loan approved date, or loan rejected date. We can calculate the difference, right? Between these 2 dates, number of days to approve. Then you can drop these 2 columns and you can keep the number of days as your number of days to approve or number of days to reject as one variable, which is a numeric variable. which will add value to your model. So dates you have to deal with like that. Dates, it's very complicated. Dates you have to be very careful. Before deleting dates, you always see whether we can extract information. Like we can do weekday, whether it is Sunday, Monday, Tuesday, we can extract month, we can extract quarter. Is it month beginning? Is it month end? Is it a year end, year beginning? A lot of things can be extracted from date. And if you have mapped the holidays list to the dates, you can also say whether that particular day is a holiday or not. So dates, we can do that. Here I have used the establishment year to calculate the age of the store. We found out the minimum age is 13 years, the maximum age is 37 years. Now this will help us to analyze better than using a establishment year as a variable. Then we have also split the data into numeric variables and non-numeric object or categorical variables. Why? Because object data must be label encoded, or dummy variable encoding must be done only on object data. It should not be done on numerical data. Never run label encoder or get dummies on numeric data. It must be done only on object or categorical data or ordinal data. Ordinal data is rank. 1, 2, 3, 4 ranks are there or ratings are there, then you can do label encoding. But do not do it on numerical data. You should not do it on numerical data. Now, there are two types of encoding. One is label encoding, which does in the same column, which simply assigns numerical identifier and it will do it override the same column. Right? It will not increase the size of the data set. Whereas getDummies creates new columns as many categories are there and uses binary encoding. What is binary encoding? Yes or no. 0 is no, yes is 1. Alphabetical order. Why it is like that? Because n comes before y. So alphabetical order. No is 0, yes is 1. Across machine learning and data science, 0 always represents no, 1 always represents yes. Until unless specified. If you want it to be other way around, you have to specify exclusively. Otherwise, by default, in all softwares, 0 is considered as no, 1 is considered as yes. Alphabetical order.
So then 3 activities.
Same thing. 0, 1, 2. Starting from 0. Alphabetical order. Alphabetical order 0, 1, 2, n levels. Whatever may be the levels, starting with them. We will work on multinomial data. We will work on multinomial data where we predict 100, we can predict 10. It depends on the levels in your predicted variable. We will work on binary data. We will also work on multinomial data. Multinomial means more than 2. It can be 3, it can be 10, it can be 20, it can be 100 also, predicting. So that large scale data sets are there. But for those large scale predictions, we have to use GPUs, graphical units. We can't use it on our systems. Okay. So we have done till this point, till the dummy variable encoding, we have done this point. Any doubts? What have I done till now? This process you have to repeat again and again for any data. Whenever you get data, you have to repeat this process. So this process will help you to understand the data, will clean the data, you will understand the variables, and you will know what to do with the data. Without doing these things, you will not be able to do anything. Understanding of data is very, very important. When you're handling data, a complete understanding if you have, it will be very easy to complete the project. Otherwise, you will never be able to complete the project. So cleaning is a very, very critical and most important task of data science. 95% of your time goes into this activity. And cleaning is not done by one person in data science only. Multiple people will be doing. So what they will do is they will split the variables. If it is a large variable data, they'll split the variables among team members, or they'll split based on categories. Numeric variables one team will handle, object variables one team will handle, ordinal or categorical one team will handle. And once all the cleanup activities are there, you combine the data into one, and then we will start working on the thing. Again, one per team will do hypothesis testing and one will do visualizations. That is how it will work. Because one person handling will not be possible. It is all team-based things where you will be working in teams and you will be handling the whatever things, because it's an ongoing process. At every step, you have to have set up meetings, discuss, understand, suggest, and then you come up with the final outcome. It will take minimum 3 to 6 months based on the data type. It will take 1 year also sometimes. So it's a very time-consuming process. You need to work very, very patiently. So sometimes you will get stuck at the SQL part only, the beginning part. Before you go to Python also only itself, you will be in SQL. Playing with getting the right data with right things is also a big problem. Because very large data sets will be there. And if the company is operating in hundreds of countries, and each country has different language, and if they have their own different databases, and if company has acquired a lot of companies, they have their own databases all integrated into one, getting the data from such scenario will be very, very difficult. That's where the cleaning process happens. CBRE, a real estate company, which recruited from PG 18 and 20, almost half of the people are working on data cleaning using SQL, because the company acquired a lot of companies and their databases have to be integrated into their database. The company itself is changing their database from a commercial database to an open source database. So it's a big problem. All the data has to be mapped, correctly done, written into proper database. They are doing this only last 4 or 5 months. Because until the database is ready, proper and all, we can't use it, right? With what you call insufficient data or data which is not complete, you will have a problem. So sometimes you'll work on the data only for one, it will take time. Once you have the database ready, then you can work on your machine learning and all those things. So most of the companies right now are struggling with the databases and the type of data they are getting. Once you have proper data only, you can build machine learning models. Now, data transformation. We have discussed one of the things called data transformation in our pre-processing. There are different data transformations for different dependent variable Y. And there is a different set of data transformation for independent variables. First, let us understand our dependent variable Y data transformation. So all of you open the notebook and run all the cells. Whenever you open the notebook, cell, run all the cells. Okay. And if you want to use the notebook, which I have sent you the previous day, you have to go to the path. If you change this path and give the folder path, your path, you can use my notebook. Whichever I am sending to you, you can use. All you have to do is change the path to your data folder. Just change the path to your data folder and you can run all the cells. You can work on the notebook which I am sending. Okay. Only change you have to make is give the path of your folder here. This is my path. Just change the path to your folder. You can work on this workbook itself. And make sure there should not be empty cells. There should not be any error cells. Okay. Whenever working, keep your notebooks clean. No errors, no empty cells. Okay. So in this data, the dependent variable is what? Item outlet sales. Oh, okay. Our dependent variable is mixed type as of now. We will do the dependent variable transformation later because we have test also, right? So we will work on data transformation of independent variables. Because our data is mixed type. Yeah. Sale is
empty. You asked me if the cell is empty or not.
which cell is empty? Achha, this notebook. Run all will stop. The execution will stop. The execution will stop at that point. After that, the cells will not be running. The execution will stop at the empty cell. After that, whatever cells is there, it will not be run. Same thing with error. If there is an error, execution will stop there. After that, all cells will be not run. The notebook will stop there only. Empty or error, it will stop at that cell. It will not go ahead and run all the other cells. So you have to correct it, and from there you have to run again all the cells. Run all below. So numeric calls. See, transformation must be applied only on numerical data. Do not apply data transformation on label encoded or dummy encoded data. Data transformation must be done only on numeric variables. It should not be done on dummy encoded or label encoded variables. Transformation must not be done on dummy encoded or label encoded variables. It must be done only on numeric variables. Numeric calls dot head. So we have these variables in numeric calls. Okay. So first thing we talked about is standard scalar. We talked about standard scalar or standardization. Standard scalar or standardization, which is nothing but Z scores, which is X minus mean divided by standard deviation. Let us apply standard scalar on this data. Except item outlet cells, we will apply the standard scalar on the data. From sklearn dot preprocessing, import standard scalar. From sklearn dot preprocessing, import standard scalar. Scalar is equal to standard scalar null brackets. Scalar is equal to standard scalar null brackets. Numeric underscore scale is equal to numeric calls dot I location square bracket column comma. What were the columns? 0 colon 0 1 2 3 3, right? 0 1 2 3. 0 colon 4 dot apply scalar dot fit underscore transform. Oh, another. What is the error? Okay, expected a 2D array, got 1D array. Okay. So scalar dot fit underscore transform numeric calls dot I location square bracket colon comma 0 colon 4. PD dot data frame numeric scale dot head. Columns is equal to numeric calls dot columns. Oh. So this is the process of applying standard scalar on numeric columns. Scalar is the name, short name we are giving to the function. Scalar is the name we are giving short name to the function. Fit underscore transform is the function for applying the scalar. Fit underscore transform is the function predefined to apply the scalar. So it will calculate each column's mean, it will calculate each column's standard deviation, then it will calculate the z-score for every value. Now, like I told you, whenever you run any process, the output will be NumPy arrays. Whenever you do any computation in Python, the output would be NumPy arrays. Now NumPy arrays, if you want to see how to write an iterator and all those things. To avoid that, simply convert the output into a data frame, and then you can see the output very easily. So I just converted, because once you apply the transformer, data structure will change from data frame to arrays. Now we are changing it back to data frame using the simple function called pd.dataFrame. Columns is equal to column headers. If you don't give column headers, you will get the numerics 0, 1, 2, 3. So
we have to evidently have to include all the columns.
see, generally we give the actually we have, if you don't have that item outlet sales here, we can simply say columns is equal to numeric calls dot columns. It's a list, right? It will automatically input it. But the problem here is we have 4, but the list is 5. Item outlet sales is also there, no? That's the reason why we are manually typing. Otherwise, simply say data frame dot columns. It will impute the column names.
So after splitting the data, we can get outer cells, we can do.
Yes. Numeric data only you can do transformations. Scalar. You can see, right, both negative and positive values in standard scalar. Okay. You didn't give brackets here. Where are the brackets? Function brackets, if you don't give, positional argument error will come. See, whenever you get positional argument error, that means you have not given brackets to the function. Debugging for positional argument error. When your argument says positional argument given, not given, X or Y, that means you forgot to give the brackets next to the function name. Just add the brackets to the function name. If you don't give it, you will get an error. Positional argument error, X or Y. Once you're done, please tell me.
So why we calculate that? Scaling the values standardization.
When you have data in different mathematical units. So we have data in 9.3, 19 like that. We have data in decimals. We have data in hundreds. We have data in tens. Different mathematical units, right? This is in tens. This is in hundreds. This is in decimals. This is in singular values or what you call tens, 20, maximum. I think maximum item weight will be somewhere around 80 or 90, right? So we have different mathematical units, right? When you have different data in different mathematical units, what you should do? That's what I told you, independent variables in mathematical units like this. Scaling must be done. When your data has different mathematical units, like one is in tens, hundreds, thousands, lakhs, you will see that. In real-time data, you will see a lot of such data. There you have to apply scaling. Got it? And for multivariate data, one of the first thing we apply is standard scalar. Standard scalar is the preferred for this. Okay. Standard scalar is the first option. It will give you both negative and positive values because some will be greater than mean, some values will be less than mean. So that is the reason why we need to transform. Okay, transformation has to be done when your data is in different mathematical units, which you can see in our data. Sometimes when you have very large data, you don't want negative values. You have large data and you don't want negative values. And you also want the values in a fixed range. Like I want all the values to be between 0 and 1 only. When you have large data, when you are running complex algorithms like neural networks, deep learning models, these are very, very complex algorithms, complex calculations are there. The number should be as much as possible smaller. There, I don't want any negative values. I want only positive values. I want all the values to be in a fixed range, like 0 to 1. When you have such scenario, we will use normalization or min-max scalar. Normalization or min-max scalar must be used when you do not want negative values. First, I don't want negative values. Second, I want the values in a fixed range, like 0 to 1 only, between 0 to 1 only. And the algorithm is highly mathematical and computational oriented. It's better to have a fixed range values. These are the reasons why we use min-max scalar. Otherwise, first preference should be given to standard scalar. It's a wonderful scalar, it works well. But if you don't want negative values, because in image processing data and all, you cannot have negative values. In some types of data, you can't have negative values. Negative income cannot be there. Right? If income is there, you're scaling the income variable, it becomes negative income, right? It's a problem. So when you have such things, the second type of scalar we use is min-max scalar. From sklearn dot preprocessing, import min-max scalar. Min-max scalar is also called as normalization. So normalize is equal to min-max scalar. Numeric underscore normalize is equal to normalize dot fit underscore transform. You can copy from the top. Numeric calls allocation 0:4. Because I am avoiding item outlet sales, because that has text data, it will give you string data found error will come. And you can copy the data pd.dataframe command and paste it down. And you can change numeric scale to numeric underscore normalize. Everything is same. Now you can see all positive values you will get, no negative values, and all the values you will be seeing between 0 and 1. Sorry. So this is one of the common interview questions. What type of transformers you use on different types of data? If it is image processing data, we use normalization because we can't have negative pixels. And for if the data allows negative, if the problem type allows negative values, you can go with standard scalar. Highly computational intensive, min-max scalar. Because negative values will cause problem in derivatives and high-end calculations. Infinity will come, right? Some cases, negative values will give you, infinity problem. It will give you infinity values. Then again, what will you do with infinity values? To avoid that, we avoid negative values. Yes, you can use. See, normalization is preferred, like I told you now, when you don't want negative values. When the computational is intensive, when you have very large data. Say 10 lakh rows data is there and you are planning to use advanced algorithms like random forest or neural networks that are very computationally intensive, gradient boosting, XGBoost, which are very computationally intensive. They are very complex mathematical calculations. There, better avoid negative values. In calculations, we don't want negative values, right? We all prefer very positive values. Computations works faster on positive values. That is where min-max scalar can be used. Not that it has to be used in image processing only. If we use, wherever we use, we have a lot of computation to be done. Where the algorithm is very complex mathematically, there you have to use normalization. Okay? Because we will, once you go through the algorithms, you'll understand this. Once I explain the calculation of each algorithm, you will understand how much calculations, we will do the actual calculation in Excel. Hand calculations we will do in Excel only. For every algorithm, wherever is possible, we calculate them. Everything will be done. Whatever we are discussing will be calculated manually using Excel. It's as if you are using pen paper calculation only. All right. Done. The next type of scalar is robust scalar. when you have outliers in your data. When your data is highly skewed with many outliers, the best scaler is robust scaler. The only utility of robust scaler is when you have lot of outliers in your data. If outliers are there, normalization will also work. Normalization also will work because it will bring the data to 0 and 1. But compared to normalization, robust scaler has better performance in case of outliers. It's proven multiple times in data. When there are outliers, you can use normalization and you can also use robust scaler. But robust scaler has a slightly better performance compared to a normalized or min-max scaler. That is why in industry, when there are when all your numeric variables are having outliers and highly skewed, better implement robust scaler. Or you can also implement min-max scaler, because min-max scaler will also bring all the data to 0 and 1. So when there are outliers in numeric variables and they are causing problem in your model building, you have to either use min-max scaler or use robust scaler. From sklearn.preprocessing, import robust scaler. Robust is equal to robust scaler. Now, what does robust scaler use? X minus median divided by third quartile minus first quartile. Right, it uses quartiles. Numeric underscore robust is equal to robust dot fit underscore transform you can copy from the top and you can copy the PD data frame command also. Control C, Control V. See, robust scaler also gives you negative values.
For example, we have so many outliers in the data, and we want to use it in computation.
You have to use advanced algorithms. So there are algorithms like decision tree, random forest, not neural networks, gradient boosting. These are the algorithms that are not affected by outliers. Tree-based models, we call them as tree-based models. Single tree model is decision tree. Multi-tree models are random forest and gradient boosting. Nowadays, you have extra trees classifier, extra trees regressors, conditional inference trees. A lot of tree-based models are there. Now, these tree-based models are not affected by outliers. They perform well and they adapt. They are suggestible. But neural networks get affected by outliers. Yeah, we have not gone into dependent variable yet. We'll do that on dependent variable. You can see dependent variable thing will only be done before model. Before building the model, you have to do that. This is the process. What I'm talking is these are all methods for that only. Skewness, kurtosis, outliers, and different mathematical units. If your data has in different mathematical units and has skewness, outliers, and all those problems, you have to use these three scalars. Getting it right? So that's what logarithmic transformation is done only on dependent variable, not on independent variables. For independent variables, we use these transformers. That's why I'm telling you there are different transformers for different dependent variable and independent variables. Dependent variable also will execute, but because it is both alphabetic and numeric, we have to get the data back, and generally we do it at the end before we build the model.
So like in this case, item object cells are numeric and offset. So after doing dependent variable, we need to then again apply this.
Yeah, dependent variable only, na? No, only on dependent variable we are applying, na? That we will see. Wait, don't hurry. We'll go in a process. Everything will be done. You have to follow the exact process which I am doing in your data science. So, where is that thing here? See, in Python only you will see a lot of research papers. See, compare the effect of different scalars on data with outliers. You can read this whole thing whenever you have time. They have implemented different scalars on this California housing data, which has outliers in independent variables. Okay, so you can see this article will tell you they have implemented standard scalar, min-max scalar, max absolute scalar, robust scalar, power transformer, quantile transformer, normalizer. So there are a lot of scalars, but the one which we use in industry are three. In academic, we have even more. Okay, so you can read this article, compare the effects, how each transformer affects the data. So here we have median income, house age, average rooms, average bedrooms, population, average occupancy. These are the numeric data variables, and then they are applying and comparing each transformer's performance, how it does, how it will do, what happens and all. So you can study this and you can refer to them. In industry also, when you go and work, you have to constantly refer to these papers. If client asks, how why did you use it? You can quote from this paper. So these things you have to do. Compare the effect of different scalars on what type of data and all. Reference points. And many scalars are there, but we use only certain amount of space here. Really? Batch number 24. 24. Break 11 o'clock. 11. 5 minutes. So just look at these various things. So like you'll compare them. I'm trying to get the comparative diagram, but I'm not able to see it. Where we can find the difference between all the three scalars. Generally, we find for standardization and normalization, but robust scalar. Okay, let us go with this. Copy image, data pre-processing. So here, the difference between standard scalar and min-max scalar. And which algorithms you should use? What? Let me just reduce the size. So scalar will change the distribution. Another thing is scalar will change the distributions. Distribution is like normal distribution is one of the popular. Normal distribution, binary distribution, S-shaped curve, binary distribution, Poisson, exponential, lot of gamma distributions are there. Distributions are there. So scalar will change, standard scalar will change the distribution, whereas min-max scalar only changes the range. For linear and logistic regression, standard scalar. For KNN and artificial neural networks, min-max scalar. These are algorithms. Cluster analysis, PCA, linear regression and all, you have to use standard scalar. For image processing, K nearest neighbors, artificial neural networks, because neural networks are very, very complex. Very, very complex networks. So there we use min-max scalar. Yes, we have to remember them. See, the more these are very simple to remember, not that they are complex formulas. If you understand the function, you will automatically remember it. Right? Min-max means what? Min and max are used for scaling. Right? Z-score is nothing but mean and standard deviation are used for scaling. Simple, one-liners. You have to remember like that. Because you have to remember certain amount of formulas. Interviews, they will ask you. They will ask you in interviews, or they will ask you in MCQs, or the written test questions they will ask you. MCQs also they are asking formulas and all. So you need to have this understanding of basic formulas. And these are not that complex. These are simple formulas you need to remember. Okay. And these notes is very, very important. Even once you go to the industry, you have to refer them. That's why I shared them on PDF so that you can save on your mobile phones also. Yesterday also one person called me from PJ22 saying that, sir, your notes only helping us. Because nobody will help you in the company. The PDF files, if you save them on your mobile phone and all, follow the process, understand the concepts, and then it will be easy for you to work. Otherwise, in industry, nobody will help you. That you have to take. You have to learn from YouTube. You have to learn from web-based articles. Sometimes you have to put queries on what you call GitHub and all. You have to, there are Stack Overflow. You have to write query on Stack Overflow. I am having this problem, help me. You will get the solution from there. From other people will help you how to do. We also refer to I also refer to Stack Overflow only, right? If any get problem is there. So you have to do that constantly. If you know answer in Stack Overflow, answer it. If you know the answer on Stack Overflow questions, I encourage people to do that. You will also learn, right? So whenever you register yourself as Stack Overflow, whenever any questions related to anything, you can choose your topics. If questions comes, you can also answer them. You can also suggest them, whatever you can do. That is the way you have to learn. Because this is a very, very complex, large subject. Statistics, mathematics, all are involved here. Not that I'm scaring you, but once you follow the process which I'm teaching you, you will find it very easy to learn. Okay. So just follow the process which I am telling you. Just blindly implement, you will do. Because this process is what I have personally used and found it successful in various projects. Okay. Yeah. Yes, there are a lot of startups and all. Sometimes what happens is, if the company doesn't want to use cloud-based computing, they see what happens is still cloud is not accepted in a lot of industries. So what happens is computing power problem will come some point of time. Now, if instead of buying servers, which cost you lakhs of rupees, you outsource that project to a subcontractor or some vendor who can buy it on cloud, run the models on cloud and tell you whether they are successful or not. If they are successful, then you can go ahead and tell your management that, see, this we have experimented, everything is run well. We will invest in either cloud or buy servers and we will build the models and we will run them. That is how it happens. So what companies do is they give to the cloud guys. Cloud guys will run it using machine learning algorithms, and then they'll tell them which is working and all. If it is working, then you go back and tell them, see, this is what, either they buy cloud, most of them will move to cloud only. They'll take over the cloud models which you have built and they'll use them, integrate them with your database, and then use them. Or if they want a physical thing, you give the computing power requirements to them, that many servers and all they'll invest, and they'll run it on their own premises. So that is what is happening. In banks also, same problem, BFSI. Because highly regulatory oriented, right? All data cannot be used for machine learning and all. So wherever some data which is non-core, they give it to vendors and they'll ask them to build, like HR data. They want attrition rates, who will leave, who will not leave. Probability model built for every employee based on the various parameters. What is the probability this employee will stay or this employee will leave? Attrition models, promotion models, clustering models for identifying performers and non-performers. So all these things you can do on data. And if the data is large, it has to be done on cloud. Because there you can rent out as much computing as you want. And it's cheaper compared to the physical cost. Compared to the physical cost, it's cheaper. Okay. So any doubts in scalars, transformations? Right? So we will be working on this on regular data sets. Every time we will do it. By end of this, you will remember the formulas. Because you will be, if you implement it 10 times, you will automatically remember it, right? So if you implement it 10 times, you will automatically implement. So we will work on multiple data sets. We'll implement these things on all the data sets. Wherever we work, we follow the same procedure, same process, and then we will then you will remember the formulas automatically. Okay, so we have done whatever pre-processing can be done on this data. We have done it. Now we can bring the data back to normal shape. So combine df underscore clean is equal to pd dot concat square bracket numeric calls comma object calls. We will take dummy or label encode. Label encode will take comma axis is equal to 1. Column pasting. In the top, when you're combining HR data, we are doing rows. Here we are pasting columns. That is why axis is equal to 1. Okay. Or we'll take the scaled version. We have already done now. Numeric underscore scale and objects label and code. Sure, sorry. So copy this command. Numeric underscore scale is equal to, remove the dot head. Index error is coming. Numeric underscore scale dot head. See, index I have removed, but still we got index error. Acha, drop is equal to true. I forgot drop is equal to true. Reset underscore index drop is equal to true. Hmm. So reset the index and then combine the data frame, both. Index is a mismatching of row numbers. So duplication is happening. So we have to reset the index of both object label and code and scaled data. Then combine df underscore cleaning dot get. We get the values. See here, the numeric values. Oh, once we take the scaled data, first convert the scale data into data frame, then the reset index and drop the index, the row indexing, you have to drop it in both the data frames. Then we are concatenating it.
If you remove drop to what's the default value?
Indexing, row numbers we are removing. Because it was giving error saying that re-indexing problem is coming up. So whenever you see a re-indexing issue, you have to reset index and drop the row numbers in both the data frames which you are concatenating. So reset index will bring the row numbers out of index, creates a separate column. We don't want that column. So that's why we are using drop is equal to true. Otherwise, once you reset the index, it will create a new column called index, and 1, 2, 3, 4, it will add. We don't want that column. That's why we are dropping that. If you say drop is equal to true, it will not create a column in our data. Otherwise, it will create a column called index. If you use drop is equal to 2, it will remove the index, but and it will not create the new column also. And once you go to industry, you will not work on Jupyter notebooks. You will work on PyCharm deployment thing. Ultimately, even if you work on your notebooks, your production team will say, no, I want the code in PyCharm only. Or whatever deployment thing they are using for deploying the model. You have to give the final code into same thing, just copy the cell-wise code into one text file and put it in PyCharm, that's all. PyCharm is another interface available for Python, which is production oriented. Deployment of model and server environment, we use PyCharms. Or we want to convert this into an application. Intranet application or web-based application, we have to use PyCharm. So at the end of the sessions, last time, I'll tell you how to deploy the model using PyCharm. So that will be done at the end, for the last sessions. I'll tell you how to deploy. Hello? Ekronoma? లోపలికి రా స్ట్రైట్ గా వస్తే లెఫ్ట్ సైడ్ 5వ అపార్ట్మెంట్ సాయి మోహన్ ఎన్క్లేవ్ సాయి మోహన్ ఎన్క్లేవ్ పింక్ కలర్ అపార్ట్మెంట్ కనపడిందా? ఇప్పుడు ఎక్కడ ఉన్నావమ్మా? ఓం శాంతి తర్వాత 2వ అపార్ట్మెంట్. ఓం శాంతి పక్కన పూర్ణిమ మ్యాన్షన్ పక్కన సాయి మోహన్ ఎన్క్లేవ్. ఓం శాంతి తర్వాత 2nd అపార్ట్మెంట్ పూర్ణిమ మ్యాన్షన్ తర్వాత సాయి మోహన్ పింక్ కలర్. 3rd floor 302. 3rd floor 302 కార్ కేసు ఇస్తారు. ఓకే, done. Others, anybody? You are getting it, right? Yeah. 1 second, I'll sort it. Now, see, we don't have the dependent variable here. We have to add dependent variable because we have removed it now when you're scaling it. So we have to add. So combine df underscore clean square bracket single quote item underscore outlet underscore sales. So the process of creating a new column in Python is data frame name square bracket the new column name. By default, it will create, do it at the end. Later, you can change the position. Okay, you can alter the position of the columns later, but by default, initially it will put it at the end. So numeric calls dot item outlet sales. Same problem, I think, index issue only. Cannot re-index on duplicate labels. Numeric calls is equal to numeric calls dot reset underscore index drop is equal to today we are getting all resetting the index. So this is how we add the reset the numeric calls index and then add it to the numeric scale is not defined. That means what is the name you are giving to scalar? You have defined numeric scale. Let's calculate. Okay, that's why use tab. Right? 3 letters and tab. 3 letters and tab. Don't type the full names. You make small mistakes. is not defined. Not defined means what? Spelling mistake. What is the name you are given to the label and code? Then that's it. Type. So and array. So you have to convert this scale to array. We have used scales. We are using scale. So that is the error. Most of it is all errors which are naming oriented only.
So he had new dependent name. Name is the same.
Yeah. At the end, it will add, no? We have to have the same name. We can't change the dependent variable name. So combine df clean dot head. You can see at the end, you will see that column. Item outlet sales. Right? At the end, it will add by default.
What about we added test?
We will now work on it. We have to remove it. Now we are still in the pre-processing. We are still in the combined format.
We have to remove that.
All right, done. See, not defined means spelling mistake. Or you have used two different names. The debugging for not defined means spelling mistake or you have mismatched the name. Got it? So that is the error debugging you need to remember. Not defined means either spelling mistake or mismatch of names. To avoid that, type the 3 letters, press tab. Type the 3 letters, press tab. And 90% errors are spelling mistakes and those only. You can avoid them. Okay. Done. Now, we will split. Wait, I'll come. We will split data back to train and test. Right? Figma train underscore df, new name I'm giving, is equal to combine df underscore clean, square bracket, combine df underscore clean, dot item outlet scales, not equal to test. Let me see if I can put it down. Figma test underscore df is equal to, you can type in same single line, square bracket combine df clean dot item outlet sales double equals to test. So wherever the cell value is not equal to test will be taken as train data. Wherever the cell value is equal to test will be taken as test data. Now, what we will do is we will drop the column. Big mart test underscore df is equal to big mart test underscore df dot drop item underscore outlet underscore sales comma axis is equal to 1. Clear now? The one we created after all the process we are removing. After splitting, we need that for splitting equal to not equal. Come on, error, show me the error. Hold on, see? Number array. So you didn't go numeric scale. Go to numeric scale. We didn't convert this. We didn't convert this into data frame. Numeric scale, we have not converted into data frames. Right. So here. What is the name of numeric scale? Remove this. Run again. Run the 87 running. Anywhere, you can keep anywhere. Now, that's all. Telling mistake only, I'm telling you now. Then go up. What is the name you have given us? Go up. Numeric scale. What is the name you have given here? Scale. We didn't run this class. Where is the number here? We didn't run it. If you run it, you will have the number now. You didn't run it. If you run it, you will have the number. Why is this thing cross? Cross section. అది కాదు ఇది మూవ్ చేయాలి అది అది మూవ్ చేయాలి ఇటు రాదా ఓకే సరే కానీ No, I'll minimize it. If you want it to be minimized, I'll do it to 175. Okay? Is it okay? All of you can see? No, no. Now, where will the other coming from? Okay. You did convert it into data frame. Numeric scale. You keep the score bars always. See? You give RIC scale. Where is numeric? Name is income. You did copy it properly. And keep the scroll bar always. All right. And also make your font size 125%. The screen size also 125%, so that you can type clearly within the cell.
Sir, why are we adding dependent variable?
Why?
Why are we adding dependent variable item what you see?
Because we need the dependent variable, right, to split the data. In combined DF, we are using what to split combined DF clean. But does it have item outlet cells? Initially it didn't have, right? But we need it for splitting. Is equal to test, not equals to test. So we have to add it back. Right? Then we can use that column as conditional statement. Not equal to test will be train data. Numbers equal to test. Words are there means it will be treated as test data. Now we added that column initially to concatenate. So we are dropping it finally from our test data. Right? This was added for concatenation. We are used it for splitting. Now we remove. Purpose of that thing is over, so we are dropping it. So we have to follow these steps. This procedure will not create problems. Otherwise, you will miss something, you will get errors, a lot of things will go. If you go in a processed manner, step by step, then only these projects will work. Otherwise, you will get it stuck. You will not be able to do it. So you have to follow the process of cleaning the steps which I am giving you. You stick to this process, you will not have any doubts. Right? And then when we if you work on large scale data, I will tell you how to do it. This is small data. So the next we'll talk about when you have large number of variables, how to do it, splitting based on data types and all those things. Again, one more case study we will do on data preprocessing. Again, a real-time data set. Then we'll go into algorithms. All right, done till this point. Now, yeah. 85th floor. ఎక్కడ ట్రైన్ రావాలి నాట్ ఈక్వల్ టు టెస్ట్ ఎక్స్క్లమేషన్ ఈక్వల్ టు కదా దిస్ ఇస్ నాట్ ఈక్వల్ టు no that column has numbers and text values. See, the column has numerics and a single value called test, right, is equal to test will be test cells. Not equal to test means numeric cells will be trained data, right? Now, because of this, if you look at our bigma train underscore df dot item outlet sales dot b type, it is showing as object because of the mixed data type, right? Because it was a mixed data type, numbers and text. Now it is showing as object. Whenever you have mixed data type, by default, it will show it as object. Now what we have to do? We have to convert it into float 64. So bigma train df dot item outlet sales is equal to bigma train df dot item outlet sales dot as type float 64 dot as type float 64. So we are converting the data type to float 64 decimals because it is showing it as object. Now, if I run this command again, it shows it as float 64. So this is a warning because we are converting a data frame, right? It is giving us a warning. It is just giving us a warning that you are changing the data structure of a major variable. So we have converted it into float 64. Right? Now, why? Yeah, tell me.
It is created the data.
No.
Right? For train, the previous value, will be applied to train data, the test data, the test data. Why it is showing
It retains the original data type of object. We didn't alter the data type. When it was created, original data type is object because of the mixed data type. That will be retained until unless you change it. Data will not automatically change. There is no automation in Python. We have to manually change. It will read some text as text, numbers as numbers. Sometimes, because of mixed data type, numbers are also read as text. It will read it as object only. You have to manually convert it into the required type, either float or int. Now, y is equal to bigma train df dot item outlet sales. This is our dependent variable. Y represents what? Dependent variable. X, capital X is equal to bigma train df dot drop item underscore outlet underscore sales comma axis is equal to 1. X is our independent variables. Independent variables. Y, small y is referred to as your dependent variable. Capital X is referred to as independent variables. Once you have the data in this structure, you can run any algorithm. Once you have the data as Y and X, you can run any algorithm. But bringing the data to this structure of Y and X is the most difficult task in data science. Bringing the data to this structure of final Y and X is what we were doing since last 2 days. In real-time data science, this will take days and months to get the data to this shape. Once you have the data like this, you can do regression, you can do decision tree, random forest, neural network. You can do whatever algorithm you want, you can run. So algorithm running is not a problem here. The problem is cleaning the data, bringing to a structure. That is the biggest challenge in data science. Model building is just 2% or 1% of your time. Model will be built in seconds. But bringing the data to that structure is the thing. You have to change, you have to play with variables, you have to work on structures, you have to add, delete, concat, aggregate, lot of things have to be done. Then only you can think of modeling the data. Otherwise, algorithms will not run. Okay. '87, we just check the what you call data type of the dependent variable, and then we change the variable to float 64 because it's decimal. All right. Now, one pre-processing step is left out is dependent variable transformation, right? So before that, to understand our dependent variable, what we should do? We should do the three plots: histogram, box plot, and density curve. Remember? Y dot plot kind is equal to hist. Y dot plot kind is equal to box. Do that plots on dependent variable y. To decide whether it is positive or negative skewness, we need the three plots: histogram, box plot, and density curve. So that transformation we have to do. Y dot plot kind is equal to hist. So what do you see here? Positive skewness. All the bars are onto the left side, right? Positive skewness. Y dot plot kind is equal to box, comma, what is equal to false. See, we have outliers and the box is onto the left side. Outliers and the box is onto the left side. Positive skewness. Y dot plot kind is equal to density. See, clearly shows positive kurtosis, positive skewness. Positive kurtosis means narrow and tall peak. Left side, positive skewness. So what should we do? What transformation should we do? What transformation should we do for positive skewness? Logarithmic transformation. Let us implement it. NP dot log of y dot plot kind is equal to density. Now it moved from positive skewness to negative skewness. It moved from positive skewness to negative skewness. So logarithmic transformation is not working. What is the other? That is negative skewness. Square root. Let's try square root. Now, square root is giving some sort of normal distribution. Square root is giving some sort of normal distribution, right? This is not perfectly there, but compared to logarithmic transformation, square root transformation is better. If at all you want to use transformation, you have to use square root transformation, or we will use algorithms which are not affected by skewness, like decision tree, random forest, and gradient boosting. Got it? So this is how we do the transformation. See, for positive skewness, primary strategy is logarithmic transformation. If logarithmic transformation does not work, we have to use square root transformation. If both of these things does not work, we have to change the algorithm. There are certain algorithms which work on highly skewed data also, like decision tree, random forest, gradient boosting. These are the algorithms that work with highly skewed data also. So we have to use those algorithms, right? So that is the decision we have to make. So despite we correct the skewness also, we may not get the proper model. Then we have to go into advanced algorithms, right? We will understand. Once we go into the process of algorithms, you will understand. Here, np.log for logarithmic transformation, np.square root for square root transformation, np.exp exponential transformation. For power star star 2, star star double star variable name double star 2 square, double star 3 cubed, double star 4 quadratic. Apa. Here.